Hello, everyone. Thank you for joining us today. We have a broadcast on unlocking time series data with Redis. My name is Robin Simpson, and I'm your moderator for this webinar. Our presenter today is Kyle Davis, Head of Developer Advocacy here at Redis Labs. Today's webinar is being recorded, and all attendees are in listen-only mode. At the end of the webinar, we'll process as many questions as we can. Please post your questions anytime using the question and answer widget in the control panel. We will also be sending out an email with a link to the recording for future viewing and sharing. With that, Kyle, I'd like to pass it over to you.
Hey, thanks, Robin. Today, my name is Kyle Davis, and I'll be presenting to you a little bit about time series data in Redis. And we have a pretty good presentation here. The way we'll do this, first I'll talk a little bit about Redis and what it is for those who are initiated, and then I'll actually get into time series data in Redis, and we'll go over how it's built and how it works. So bear with me if you already know Redis. There's just a few slides that talk about who we are, and we'll go from there. So first thing I want to talk about is Redis. One of the things we talk about is the database for the instant experience. One of the most important things that you should know is that the human psychology cannot perceive anything shorter than 100 milliseconds. So that's instant speed. Now, when you start building applications that end to end, whether you're on a mobile device and going through 4G wireless or I hope not 3G wireless if worse comes to worse, you still have to get that 100 millisecond time. Otherwise, people perceive it as being lagged or delayed. So we want to be the data layer for that type of application. Now, what is Redis, right? Redis is an open source in-memory database. It's used across a lot of different use cases, and it's open source, and our roots are in open source. For those of you who don't know, Redis stands for Remote Dictionary Server. It is BSD licensed, so completely open source. It's the leading in-memory database platform. It's just about 10 years old. It was created by Salvatore Sanfilippo. You can take a look at the source code if you enjoy reading C and really good C, which is, I think, rare. Take a look at the GitHub repository for Redis itself and read the source code. And if you want to learn more about Redis itself and how the commands are laid out and how you might use it, go to redis.io. Okay, so what I also want to talk about is Redis Enterprise. Now, here at Redis Labs, we're the home of Redis, but we also produce Redis Enterprise, which is a multi-model database with Redis at its core. So basically, if you use a lot of Redis or you're a large organization, these two groups, I kind of like to say if you're a large organization or you're a small organization, you use Redis like a large organization, i.e. use a ton of it, then Redis Enterprise might be for you. So take a look at that if you fall into those two categories. Now, let's talk about the community. We're over 1.5 billion Docker pools now, which is kind of an immense, incredible number. We know that there's not 1.5 billion applications running Redis right now. That would be crazy. We know they're part of CI and CD pipelines and things like that, but it still shows the volume of Redis, right? So the other thing is that we are the most loved database, and Stack Overflow does a yearly survey polling people about this. Now the last 3 years we have been the most loved database. So that's a little bit about Redis. Now let's kind of dive into what is time series data, and I think some people have some ideas. If you are a time series veteran, again, this will be a little bit of a refresher course at least. And I've taken some liberties. If you go and you read the actual definition on many different sites, they're pages long, but I think it can be simplified quite a bit. So it has a time index, and the value is numeric. So basically, if you think about it in two columns, on one column you have some sort of time index, usually timestamps in the Unix epic form, and then you have some sort of numeric value on the right-hand side. Very simple. So you can analyze it using time series or using time bound. So if you want to say what happened between January 1st and January 3rd, that's a great example of it. But you can get very granular into seconds, sometimes even milliseconds, depending on your use case. You can separate it into time units. For example, you might see what happened on an hourly basis, and then get like an aggregation on top of it, get averages per hour. So you don't have to see things on every single event that is in your time series data. Let's look at some common examples of time series data. One is stock. charts. Now, this is something most people think about when they think of time series data. So you might look at how a stock is performing over a given time period. So each one of those data points are recorded, and then that's put into what a time series type data structure. One that I look at a lot is the CPU load on my computer or on my server otherwise. Taking a look at that, you can see, they've taken the measurement of what percentage use it is utilized at a select interval, and then that's plotted in these examples. And then also taking a look at things like sensor data. In this case, we're just looking at temperature data and how it might swing. This is a very coarse granularity here because we're talking about like hours, but it's still time series data. So that's just a few examples, but really it's all around us. Anytime we're looking at trends over time, that's usually sourced in some sort of time series database or time series structure. Now let's focus in a little bit more and talk about Redis and time series, right? It all started with sorted sets. So sorted sets are one of the built-in data structures in Redis, and people started using them for time series data early on. So you'd have ZAdd, my sorted set's a key, then you had a timestamp, which was the score, and then there was a member, which was your value. So that was great, but you could only get ranges and stuff. So you couldn't do the averages or kind of downsampling type of features that you would otherwise do. However, this had some problems. So let's take an example here. Now, sorted set, and this is when I teach about sorted sets, I always say sorted is not the most important term, but set is. Set cannot have repeats. So in this case, if you have two different timestamps with the same value, the set is based off of the member, or in this case, what we're defining as the value. So if I was to do this, as this example on the screen shows, the second one would actually be an upsert, i.e. you would overwrite the first one. So it doesn't work for time series if you just use it like this. And people had some very rude awakenings when they used it that way. So the hacky solution that people came up with was that they put in junk values after it, some sort of randomized high entropy amount of data. Or the alternate way of doing it was using lexicographic sorting, where you kind of reverse some things around and you put the timestamp and the date in, and it was computationally complex, and it was also really hard to implement. I've used it before personally, and it always felt like there should be an easier way, right? Then came along Redis streams. Now this is something that came out in Redis 4.0, so it's not that old. It's been around for a little over a year. It was designed to solve some similar problems. Like you might have this idea of mainly it's used for like building application architectures. So it's not a unified log idea, where you'd have basically different processes updating, and you would read those processes back to determine the state. Similar ideas of messaging, and it would fill a lot of niches that you'd have in very large architectures. Let's take a look how it looks. It had some advantages over sorted sets for sure, especially when you try to use it in time series use cases. And you had this idea of putting a key in. This little asterisk was saying let's get an auto-generate an ID, which is actually based on a timestamp. Then you can have per sample. So each time you have something in time series, it's called sample. Field value pairs. So you could actually go through and do things. So if you see here, I had field was my value of 1,000, and then the second time I entered something, I had my value of 1,000. So that's one field value pair, and then another field and hello. But still had it was lacking some features, right? And it really wasn't designed for it. And anytime you take something and you figure out a secondary use for it, it's always missing something. So you can get time ranges very easily with it, but not a whole lot else. And there are some other missing things. Now, if we rewind a little bit, we can talk about the modules API. The modules API came out a little bit before streams. Basically, it allowed Redis to have additional commands and data types. So anybody who could use a systems programming language could build a module, and that module would then act as a first-class citizen inside of Redis itself. We've developed modules. One of the first ones was Redis search. We have a graph module that allows you to do graph queries across graph nodes. We have a JSON module. All these things were not built into Redis, but they operate as if they were when you have the module installed. And we have recently been working on Redis TimeSeries. Redis time series. It's basically an entire time series database inside Redis. So I'm a technical guy, so I want to make sure that everybody knows how it works. So I think it's very important when you learn any type of software that you know kind of the internals of it, just so you can fully understand what's going on. So I'm going to go from the most basic part, the pretty low level, all the way up into how to use it pretty quickly. So stay with me. So the first thing I want to go over is the chunk in Redis time series. So this is something that you actually never manipulate directly, but this represents the chunk. So all the data is stored in these chunks. And the chunks are effectively two arrays that are in a linked list. And you can see I have previous pointer and next pointer. These two arrays are correlated, so you have timestamps and sample values. So this is mapping directly to what time series is. So as an example, let's say I have this timestamp. I'm going to go ahead and put that into my time series database, and you can see it goes on the first row in the two different arrays. So if you have additional rows or additional samples, they would just go in to the additional rows going down. Now, what's really cool is when you fill up your chunk, it is of a fixed size when it's created. It automatically goes to the next chunk. So what does this tell you? So you have the previous and next pointers, right? Like if you're familiar with linked lists, they're really great about reading the front or the back or traversing the entire amount. But in the middle, that's where you start having to realize it. We have some optimizations built in, but it does work really well to get, especially those adding things on to the end, for example, is a very simple operation. So let's look at this. You'll have multiple chunks, so you can see it being arranged like this with the traditional kind of linked list thing. But unlike most Redis functions, actually data types, you have to first create your time series key. Now there's ways around it in Redis time series, but I think this is the best practice. So in this case, my command is ts.create, and then I have my ts, which is the key that I'm using here. So in this case, let's say that we want to add in some metadata about this. Let's say we're a greenhouse type of situation. You have a plant, let's say a cabbage in a certain greenhouse, and then those two things are for all the samples. So if you can see here how we do this, we have what's called labels. So we have plant and cabbage 47, location and greenhouse 4. So this applies to every single sample. So it's important to know this is across the entire time series. So as you can see, we are using the same familiar field value pair type of thing. So it's pretty easy to look at. Now, the other thing that you can look at, and this is an important part of time series, is retention. And in this case, you might have different chunks and inside those chunks, they have samples that are of different ages. So let's say that we don't care about anything that's past 60 seconds, right? So what Redis time series will do when it is available, it's a lazy operation, so this doesn't happen instantly, but it will start trimming off things that are past your retention time period. So if you see we passed 60, and it trimmed off that entire chunk that contained things that were older than 60 seconds. You can set that any value, and most things in Redis time series are based on the idea of seconds. So that's kind of our granularity here. If we take a look too, we can add values in, and that's done by a simple operation called tsadd. The first argument is my ts, and I've got an asterisk there. That's some syntax borrowed from the streams data type. So this adds it in. You can see here, and our value is 834. So let's add another value in. You can see I've added it to the chunk on the right, and that one line is lit up. Let's add another chunk to it. And this time I'm going to specify a timestamp. And you can specify timestamps, but I will let you know that you can specify a timestamp, but it is effectively pinned only past that. So you can't go in and add something in the middle. And that's where this whole linked list thing kind of comes into play. But this is really meant for additive things. So the subsequent tsadd would have to be a timestamp greater than that value, okay? As a reminder, we have the two different values, one going into one side of the array inside the chunk, and the value go on the other side of it. So if we take a look at this, we can see how that looks if we get a range. So this is how you would actually go through and get a bounded result. So you want to say, I'm between these two timestamps, give me all the results. So in this case, we'll just use our example, and we're saying we're getting those two values. And you can see we got 834 out. Is the first one we put in. The second one was 1,000, right? So that's useful, but maybe you want to do something a little bit more. Maybe you want to go in and get an average based on every 30 seconds. So in this case, I put my time-bounded values in. I'm using aggregation. This is a keyword inside of Redis time series, I should say. And then we have average. So AVG is our keyword to say I'm averaging, and then 30-second chunks. So our 30-second buckets, not chunks. We take a look at this. What this is going to do is going to find the earliest. It's going to find the cutoff from that. So that's the first result. So that's that timestamp, and then 917. Of course, that's the average of 834 and 1,000. So moving forward, let's take a look at when you have a lot more data. So this is only a small part of it over many seconds. And you may want to say, I don't want to run that TS range command all the time. I just want to get that data out in a granular way. Well, we have the ability to create rules. So let's say that we're going to do this, and we have my TS, which is my timestamp. That's the source, and the destination is going to be my TS2. That's the second key. I'm going to aggregate that, averaging every 30 seconds. So all of these chunks here represent 30 seconds worth of time. And then what's going to happen is automatically, without your intervention, it will actually put that into the secondary key, the destination key. So as every 30 seconds passed, you'll get one more sample added to my TS2. So you can really create these, both having a granular way that drops off the end, right? So maybe you have a very specific 120 seconds that you're sampling every second or every any particular interval, but you want to create 30-second increments after that. So it would actually go through, you create the rule, and you'd have a downsampled way of looking at the world. Very, very useful. So the other things that we can do, it's not just limited to averages, but you can sum. So this would do the same type of operation, but add them all up. You can get the minimum, you can get the maximum, you can get a range. So what's the range of values? You can get the count, how many, the first or the last. And all of those different aggregation functions also apply for TS range, right? So that's how Redis time series works, which it's amazing all the things it can do. But let's take a look at what else it can do that I haven't showed you. I'll spend a few minutes on these. The additional commands are ts inker by and ts decker by. This is for counting over time. What these do is actually pretty interesting. So ts inker by will go and say, what was the previous entry, and increment it by some value, okay? So in this case, let's say that you know that in 10 seconds you have collected 10 widgets, right? So then you would do ts inker by my time series, and then the next argument would be like, let's say 10. And in this way, you don't have to know the previous value. The same applies for ts decker by. So let's say you lost 10 widgets in your factory or whatever you're using. Then you would do ts decker by the key, my ts or whatever it might be. And then you would do 10, and it would decrease the value by 10. So this is great for doing kind of like, you would get a count by just getting the last entry or the last sample, but it retains a history over time. And of course, you can do all the things that you were doing before, like having a rule set up where you might say, okay, now we're looking at it from a minute-by-minute basis or an hour basis, so on and so forth, getting averages or mins and max. TS-get, which is kind of related to the previous one, because what it can do is it can actually get the last value. So if you didn't want to use ts-inker by, you could get the value and then manipulate it in some way and then add it back in, but I think ts-inker by works better for this use case. ts-alter allows you to change your metadata about the key that you created. So let's say that we're going back to our greenhouse example. You did have cabbage 47 in greenhouse 4. Let's say you made a typo and it was actually cabbage 48. You could then update those fields and values or add more in. and also change the retention and do all the different things that you would normally do at creation time, but afterwards. And then we get into these are very compelling commands, the tsmrange and tsmget. So this is a really interesting part of time series that is a little bit complicated to explain, but I couldn't come up with a great visual for it, so I'll just try to describe it to you. Um, Basically, what you have here is Redis time series keeps track of all the different time series keys in the database. So when I say tsmrange, you're able to specify a key value pair. So for example, in our greenhouse example, give me all, we're talking about greenhouse 4 that might have thousands of cabbage plants. I don't know why I'm using cabbage today, but we're using cabbage. So tell me all of the temperature readings for greenhouse 4. And then you can use tsmrange, and it will go through and look at many different keys across the entire key space. So very cool thing you can do there. tsmget, as you might probably understand, is very similar. In this case, what it does is it allows you to get the most recent value using the same key value querying ability. So super interesting things. And you can also as well do the kind of basic aggregation stuff that you were doing before as well. So really powerful functions that you can do this. And it's unusual that in Redis that you have any type of operation that goes across multiple keys without specifying those keys directly. So there's definitely some interesting secret sauce there. It's not secret, by the way, but you know what I'm saying. It's definitely some interesting programming going on there. So you can connect it with many different parts of your infrastructure. So it's able to connect with Prometheus and therefore with Grafana, which is great for monitoring dashboards. And this is where we see it being used a lot. One of the great things about Redis time series is that it is, of course, Redis, and it's optimized for very quick insertions. So if you are monitoring some sort of metric that's coming in very, very quickly, because Redis is working as the store for Prometheus, it can be very, very quick. And remember, with in-memory databases, they operate at the speed, reading and writing are at the same speed, right? So for the most part, what that means is there's no delays that you might be going to a disk and writing to a disk. We're simulating that on SSDs. So really great for high volume situations where you might have a lot of data being thrown at your dashboards. You could use it in IoT situations with Redis Edge. So for those of you who aren't familiar, Redis Edge is a collection of Redis modules and Redis open source that's designed to work with this particular SDK. So you can run Redis and do some very interesting edge computing on devices like, say, a Raspberry Pi or other single board computers. So in that case, we see it as a great as a really great companion in IoT situations, because IoT situations are notorious for having very heavy workloads with all sorts of sensor data coming in, and being able to make sense of that or do anything with it requires something where you might want to do downsampling, as an example. The other thing that I wanted to go over is caching your most recently used time series data in Redis time series. And we've been talking to people throughout the industry and trying to figure out, okay, where are people using time series data? And we've got some different use cases for sure. But a lot of people are still storing their time series type data in relational databases. And of course, that's not a great fit technology-wise. There's a lot of reasons why you wouldn't want to do it, but a lot of people are stuck in the situation where they are writing time series data into relational databases. And you know what? They're having a heck of a time scaling things. Whether that might be, it might have worked fine when you had 2 or 3 people looking at a dashboard, as an example. But when you scale up and you want to be a data-driven organization, and you want thousands and thousands of people to look at some sort of analytical dashboard every day, no longer will the ad hoc queries that you're doing in, say, a relational database, they won't do. They'll work, or you'll have to spend great time and effort to scale them. So we see Redis time series being used as a way of caching time series data that would otherwise be used in a slower database. But so I'll also say that it's fine on its own. So if you do have a use case where you're not doing any type of caching, we come with all the benefits that Redis has, which include the ability to persist your data using various different tunable persistence methods, and as well keep it ephemeral if you don't need that. So it's really your choice at this point. So I want to wrap up. This is not a very long presentation, but we'll leave some time for questions. One thing I want to talk about is how you get started. Go to Redis TimeSeries.io. This will actually forward you somewhere else, but it's a great resource to start learning about this. You can launch it in Docker, and one line, if you have Docker running on your system, it's just one line to go ahead and launch it, and that'll start a new Redis process, which you can then connect to through Redis CLI. And you can try it out without having to mess with building it or doing anything like that. So really great way to get into starting developing for it. You can build it yourself. You'll need all the tool chain that comes with it. It's not hard, but that's always an option. For me, I like to build things myself because I like to kind of see it all happen. And the other thing on Redis TimeSeries.io is you can look at all the different commands. Now, the different commands, I was not 100% exhaustive in what I showed you today. There were a few other ones that you know, you'll get started right by looking at these commands, and we'll be sending this out later. But you can go through, and that's our official reference guide. The other thing to do is take a look at the GitHub org for Redis Time Series. Now, as I alluded to, one of the great things about Redis Time Series is that it can be used to connect to different things. So for us, it wasn't ideal to have a single GitHub repo. You know, so we have an entire org that contains the module source code, as well as connectors and examples. So take a look at that, github.com/Redis Time Series. Now, one of the interesting things that we're doing this time is I didn't develop Redis Time Series, but my colleague Danny, he did. So we're going to have an interview with Danny on Tuesday, July 23rd at 9 a.m. Pacific Standard Time. Now, we just scheduled this, so this will be something that we are going to be putting on our website, where you can RSVP for it very soon, next few days. So check out redislabs.com, and then we'll do that, and we'll have a question and answer directly with Danny. So if you have questions that you want to understand his motivation for building it, we can do that. And you know, the other thing that we could talk about too in this particular part is that you know, we're actually you know, I talked about like where it was being used, but one of the reasons Danny developed this is because we use it inside our own product, inside Redis Enterprise. Redis Time Series is used to collect metrics. So he can talk about how he scratched his own itch by building this module. So really interesting stuff. So I want to go ahead and open up for questions. I've got a few here that have come in. So there's still time to ask questions. If you do have one, go ahead and put them in the chat widget, and that'll get over to me. Okay, does this work in a clustered Redis installation? The answer is yes. There are facilities to do clustering on it. You know, and you'll have to take a look at Redis TimeSeries.io to look at the specifics on it. But it is designed, even with some really interesting things, to do that. Now we're based on keys, so you'll have to look at how your cluster is set up to make sure those cluster keys are appropriate for what you're doing. But it is designed to work in a clustered environment, which is really cool. Okay, so you mentioned TS, mget, and TS range. Does it look at every Redis key? Is this O in complexity? Okay, so yeah, that's an interesting point. So one of the things that TS mrange and TS mget do is, like I said before, you could say like greenhouse 4, give me all the different ones, and greenhouse 12, and so on and so forth, where a key equals a particular value. What it does is a little bit unique. There's kind of a trick to it. So instead of looking at every single key, now that if you know anything about distributed computing, that would be very expensive, especially as you go into larger key values or larger key cardinalities. What it does actually is when you add it in, it will actually go through and index those values as you add them in. So, and then as well, if you have a restart, for example, and you're restoring from an RDB or from an AOF file, it will actually do the same thing. So this allows us to have an index that's stored outside of the key space that is able to find these values. So that way, if you've looked at Redis search, for example, you'll know that it has different key values that it uses different keys that are spread across the key space. It's not really how it works in Redis TimeSeries. So it's not ON. It would be a different time complexity than that, so much less. Can I use this with Python? So the question is, yes, it can be used with Python. There's a couple different ways you can look at this, right? Python is a pretty flexible language and pretty easy to use, right? So we can just send arbitrary commands to it and it's not strongly typed. So my personal view on it is go ahead and send the raw commands, just like you would use anything. Node.js the same way. So there are some submodule client libraries that you can use that make it a little bit more idiomatic. And it works great for typed languages as well. So that's one thing that you can do. So I built all my examples when I was doing this, and we didn't do a portion where we're doing a demo, but I used Node.js and it was very simple to use. It was adding one command in, enabled it to be used in it, and Python is very similar in that way. So it can be used in Python. Let's take a look at some more questions. Okay, are there data retention thresholds global for the whole database, or can they be retained per key? I'm actually refer back to one of my slides and show you how that works. So let's see here, retention. All right, so if we take a look at this one, right? This only applies to MyTS. So you could have retention 60 here, right? But if you had MyTS2, a retention of 1,000 seconds, 1 million seconds, or no retention at all, that's perfectly fine. So you could create multiple different keys, each with their own retentions, and that database can contain millions of different time series keys. Let's see, lots of questions today. Okay, is there any way to insert data in the past, middle of the linked list, with the understanding that it's less efficient to add it this way? No, I do not believe there is. It will trigger an error if you try to add data in the past. And that's a call, right? If you start thinking about this, and let me refer to one of my other slides as well, what that would actually mean if you had to do that. And one of the things that we have at Redis Labs is our ethos is basically, if you can't do something fast, don't do it at all. So if we're looking at this is good enough to kind of show how it works. Let's say we're looking at the middle chunk and we're talking about adding something in between, like kind of vertically in the middle, right? Because these are arrays and they're practically fixed size, that would cause a cascading effect. So you'd have like a situation where you'd have to move the sample from one chunk to another, and then another chunk to another, another chunk to another, and that would just not be efficient. So to my knowledge, and this will be a great question for Danny if you join us next time on July 23rd, to see if there's some way to do that. I do not think so. When I've tried it, it has done that, but maybe there is a workaround that I'm not familiar with. So let's see here. Okay. Is there support for non-numerical data like strings? No. The closest you get is this type of thing where you have labels, but that's a label per time series. Now, if you have strings as an example that you're trying to correlate with a particular sample, that's not something that we're really optimized to do. That sounds kind of like more of a streams use case. But this is really about analyzing the numeric values inside of it. So really not something that is within the wheelhouse of this. Now, there's probably some ways that you could work around this if you create a multiple time series and you're using TS in range, for example. You can do some things like that. I don't know if it's a particularly great pattern where you might have something that, say, you create multiple time series and you assign metadata to it, the entire time series, and you're sampling there. So if you're sampling with something that has, let's say, a particular field, and that goes in one time series key, another time series key, and you're always using TSM range to query that. But that would be a pretty complicated setup, and I would question if that's the right tool for the job. Okay. Okay, would it work with old data that needs to be fed in parallel with real-time data? Yeah, I don't see the problem with that. So, you know, with this idea, when we're talking about the TS add, and we're specifying a particular timestamp, right? What I would do, so as you're entering the data in, I would honestly take a look at that, and because you know you run into problems if you, let's say you have a real-time piece of data that comes in and you want to add something in the past, and that's violating that kind of idea of moving forward only. But there's nothing to say that you can't do this in two different time series. So for example, this would be a great use case for TSM range. So you have one key that is a time bounded for your historical data, right? So you have my TS April 2019 as an example. And that's where all the other stuff goes in. And then you have another one that's say May or June or whatever. You could use TSM range to actually go through and query those labels and find that data out. That way you're running in parallel. But to do it in one single key, I think that would be challenging. Let's just put it that way. Because you would never want to make sure that you never would want to get in a situation where you have something, the timestamp's being specified, that's going, you're going to want to add something in the middle. We don't know that. Okay. How should time series be designed? Should we create one time series per sensor, or is it better to have a global one? So absolutely one time series per sensor. So in this case, let's say we're talking about monitoring cabbages and whatever numeric value that would be, temperature, let's say. Every single cabbage would have its own time series key. So that would be totally fine. And that could be some sort of randomly generated key. It doesn't really matter. It could have meaning to it. That would also be fine. But I would definitely make each one of them their own time series and then use the mrange commands if you need to get anything off of that. I think you would be a real challenge to create one global one and somehow do some sort of specification on it. I don't think that's the way it's really designed to do. Okay. Let's see. Some of these I will defer, and some of them I will answer. I'll defer them to an expert because there's some that I'm just not. To be honest with you, I would want Danny to answer this because he'll have a better response than I would, and probably give you the color of why it is the way it is. So let me see if there's any more that I can answer. Let's see here. Yeah, I think that's where I'm going to call it. Again, please join us next time for talk with Danny. There's a few of these about replication that I would not want to answer without 100% checking that. So apologies, I cannot answer those today. But join us next time, Tuesday, July 23rd, and certainly let us know. If you have questions, I will let you know that you can go ahead and you can email them to me, Kyle, K-Y-L-E, at redislabs.com. And if I can't answer that question, I will forward it on to the person that can. Yeah. All right. Well, thanks, everybody. It's been a pleasure talking to you about Redis time series.